So, last lesson, we were looking at the oxidation states of some elements, and we could work out the oxidation state of the elements by using some reference oxidation states. The fact that hydrogen is nearly always in +1 oxidation state, oxygen in -2, atoms in group 1 +1, atoms in group 2 -2, and then usually atoms in group 7 -1, but sometimes they change. We've talked about the fact that oxidation states can change, so atoms can lose or gain different amounts of electrons. When they change oxidation state, that's either called reduction or oxidation, and we say that an atom that goes through reduction is reduced. An atom that goes through oxidation is oxidized. So if I'm looking to see if an atom's oxidation state has changed and whether it's been reduced or oxidized, I have to look for certain things. Typically in a textbook, they would say if oxygen is lost from something, say for example magnesium oxide becomes magnesium and the magnesium loses the O, the oxide bit, the oxygen. If it loses oxygen, it is reduced. If something gains oxygen, like magnesium added to oxygen makes magnesium oxide, it is oxidized, usually when something burns. If hydrogen is gained, that's reduction. If hydrogen is lost, that's oxidation. In other words, the opposite of oxygen. Oxygen lost, reduction. Hydrogen gained, reduction. Oxygen gained, oxidation. Hydrogen lost, oxidation. And then you can look in terms of electrons as well. There's a little rhyme, oil rig. Oxidation is loss, reduction is gain, and this is talking about electrons. If electrons are gained, it's reduction. Reduction is gain. If electrons are lost, it's oxidation. Now all that seems a little bit confusing. That's a textbook answer. I've got another little way of doing it that I'll show you in a minute that I think is easier. If you work out the oxidation state of something, if the number goes up, it's oxidized. If the number goes down, it's reduced. And you'll see this in a minute. Incidentally, you may have heard of something called redox. This basically says when something is reduced, something else in there is oxidized. So when you have reduction, you have oxidation at the same time. That's because reduction is gain of electrons. Well, where do they go to? Something else is oxidized because they lose electrons. So something is oxidized and loses electrons, and the electrons then are allowed to be gained by something else. A good analogy is money. Somebody loses money, they become poor. Somebody else gets that money, they become rich. You can't have rich people without poor people. You can't have poor people without rich people. Anyway, let's look at this in practice. Here's some equations. They're not balanced. It doesn't matter that they're not balanced yet. You can still work out oxidation and reduction even if the equations are not balanced. Trust me for a minute, I'll show you that in a little bit. So, according to the textbook about oxidation being gain of oxygen or oxidation being loss of electrons, it's quite difficult to get your head around. But if you do it in terms of oxidation number and whether that's gone up or down, I think it's far easier. So this is my little method. Forget that this equation's not balanced. Let's look and see if the nitrogen, which is underlined, has been oxidized or reduced. So we work out its oxidation number here. Well, we know hydrogen is +1 oxidation state. 3 plus 1's are +3. There's no charge overall, so nitrogen here is in -3. -3 oxidation state. On the right-hand side, it's on its own. It's not bonded to anything. It's not lost or gained electrons. It's 0. So it's gone from -3 to 0. Now, for the non-mathematicians, is that going up or down? Think of temperature. The temperature outside in the morning was -3. It's now 0. Has it got hotter, colder? Has the temperature gone up or down? If it's gone from -3 to 0, it's gone up. The temperature has gone up. It's got warmer. So it's gone from -3 up to 0. If the number goes up, it's been oxidized. End of. Let's have a look at the next one then, the Cl. Well, what have we got around it? We've got K, which is in group 1, +1 oxidation state, so that's +1. Oxygens are -2, and there are 3 of them. 3 -2's are -6, so I've got -6 here and +1. What number would leave no charge overall? The answer is +5. +1 +5 is +6. 3 -2's are -6. That balances it all out to leave no charge. So the Cl is in +5. What is it here? Well, K is in +1, so the Cl to leave no charge overall must be in -1. It's gone from +5 to -1. +5 to -1, that has gone down. If the number goes down, the oxidation state goes down. It's reduction. It's reduction, it's been reduced. Let's try one more. Ti, titanium, it's on its own, not bonded to any other atoms. It is in oxidation state 0. It's not bonded, it's not lost or gained electrons, it's just on its own, 0. Ti here, O's are -2, 2 -2's are -4, no charge overall, so the Ti is in +4. +4 -2 -2 leaves no charge. So it's gone from 0 to +4. The number has gone up. It's been oxidized. And I think that's far easier than some of the other textbook methods. Finally, you've got to balance them. And this is just because equations need balancing. It doesn't affect oxidation reduction. So this NH3 is going to need a 2 in front of it because I've got one N on the left and 2 N's on the right. So once I've done my oxidation exercise, I'm going to balance them just to tidy things up because it annoys me if things aren't balanced. 2 N's, now I've got 6 H's, so I'm going to put 3 waters to make the 6 H's. I've now got 3 O's, so I'm going to need 1.5, 1.5 oxygens there. But let's look at the N. Before it had a 2 in front of it, its oxidation state was -3. The hydrogens are +1 each, +1 +1 +1 is +3, so the nitrogen is in -3 to leave no charge left over. Putting a 2 in front doesn't change that. It just doubles all of the numbers. So that or that doesn't make any difference to the oxidation number, the oxidation state of the nitrogen. It's still -3. Look, -3 there, and if you want me to do the maths, 2 lots of NH3 is now 6 H's, 6 plus 1s, plus 6. So the 2 N's in there are plus 6, they must be minus 3 each. So putting numbers in front doesn't change the oxidation number, also called the oxidation state. So you can just balance them at the end and you're not going to mess up your answers for anything. Let's just put, say for example, 3 there, so I need 1.5 oxygens, and I'll do one more. That one is already balanced. 3 of them, 2 of them, and you can go down and balance them. But your oxidation numbers won't change, your oxidation states, that is, won't change, and whether something has been oxidized or reduced won't change. So for each of these, work out the oxidation state or the oxidation number, same thing for everything that's underlined. Work out whether that number has gone up or down. If it goes up, that element has been oxidized. If it goes down, it's been reduced. And then finally just balance them just to keep me, an old man, happy.